most feared of all natural disasters are hurricanes and earthquakes. The damage caused may be tremendous in just a few seconds. This is why the ultimate goal here at the Barbados Standards Authority of the Ministry of Transport Works and Maintenance is to protect the lives of occupants in buildings. Director Emil Trotman shows us firsthand how to ensure that a building is strong enough to withstand hurricane-force winds and earthquakes.
The first detail we show you is for a strip footing, typical strip footing, and this is for a wall blockwork house. You have, these are 12mm bars, 6 of them, 3 top and 3 bottom, and they're laced with 10mm bars, which are at 8-inch centers, and this is a starter bar, which is a 12mm bar, a starter bar. This type of foundation, because of reinforcement at the top and the bottom, is less susceptible to subsidence. These starter bars should come from foundation through to the roof. They start with a 8-inch hook which is embedded in the footing. There's a 40mm or 1.5-inch cover to this footing. The footing should be 2 feet across and 8 inches deep. These starter bars should be at all corners, at all junctions where two walls intersect. They also should be at window and door openings, and they also should be at rear wall ends, and also at 2 feet centers, otherwise at 2 feet centers.
Here is a corner detail where 2 exterior walls meet.
Exterior walls must be of 8-inch blockwork, hollow concrete blockwork. And these are 3 corner bars, and they're tied together by if you see here, there's an L-shape link that ties these three corner bars together, and also in the mortar joint. And these occur every 3 block courses, approximately 2 feet. Every 3 block courses, you have these are 6mm diameter bars, which are placed in the block course, and these are used instead of brick force. And these provide more resilience to resistance against earthquakes.
Mr. Trotman, do the details of the building standards encompass the construction of chattel houses?
Yes, they do. And that brings us to our next detail. First, this is a base. This should normally be a 2-inch thick by 20-inch square concrete base, usually having some BRC. And then this will be the pier for the child house. The child house, which is normally placed on loose stones, instead to be placed on masonry piers, hollow concrete blockwork piers. Each cavity would contain 1 rebar, and also you have some maybe filled solid. And if you notice, this is a timber floor beam, which is a 4x6 Purple Heart floor beam. Is only used to support the child house. There are some 16mm diameter bolts, which are 1 foot in length. Which is then anchored into the concrete pier. And these concrete piers are at 6-foot centers maximum, or a clear distance of 4 foot 8 inches between them. This 16mm bolt is also affixed to a 2.5-inch square by 6mm thick washer, and this prevents any uplift forces from the wind ripping the timber beam through the bolt head. This is the stud, a timber stud, which will be normally for which all child houses are built. These hurricane straps, which are called purling connectors, these are fixed to the timber floor beam, Purple Heart timber floor beam, 4x6 timber Purple Heart floor beam, using clouts, which are 1.5-inch diameter clouts. So as I said, there are two of these such purling clips on fixing the stud to the floor beam. What you see here, this shiny piece with holes in it, this is supposed to be a gang nail plate. They're not yet available. They used to be available in Barbados, but now we had discussions with Ace Hardware. They're going to start bringing them again. But these are fixed to the face of each face of the stud as additional support to fix the floor beam to the stud. Each stud additionally should be fixed to the floor beam using a 1.5-inch, well, these be 3-inch 10-penny nails.
The rafter to roof beam joint detail protects the roof and dwelling from a hurricane or earthquake.
This is the roof beam here, containing 3 in each face, 16mm diameter bars. 1, 2, 3 each face, and then there are 6mm diameter links at about 4.5-inch centers. You'll notice there's one dominant link, and then there's a sausage link in the center. And as I said, these are 4.5-inch centers. And these are this is the rafter. We do show a Purple Heart rafter in this case because for roof spans larger than 16 feet, you'll need a Purple Heart rafter. What this detail shows is that there's a multi-purpose strap that comes out of the concrete roof beam, comes out of the concrete beam. It comes up and over, and it wraps over onto the rafter. I forgot to mention to you that this concrete roof beam is 12 inches deep and 8 inches wide, and it always goes on an 8-inch hollow concrete blockwork wall.
Is the rafter anchoring practice being appraised now due to negative experiences with rafters splitting during hurricane winds?
Yes, the construction practice was to have the rafter, and then there'd be this through bar, which ties this was normally 12 millimeters, this bar, and this bar was bearing directly against the wood. So when the hurricane forces push against this, it caused splitting, somewhat similar to what when you drive a nail into wood, the wood will split, the nail will split the wood. And what we're doing now is that we're having this bar will be against the metal plate. So it's metal against metal, and it's less likely to get tearing. In addition to that, we have this anchor strap that comes out of the concrete, goes over and wraps around. So the chances of the rafter splitting will be greatly diminished, if not totally eliminated.
Next up is a depiction of the correct way to fit a timber-framed house on a concrete beam.
This is the saw plate, this is the stud, this is the plywood sheathing here, and this is the siding board, Purple Heart. This detail is showing you the saw plate being bolted to the concrete beam by a 1-foot bolt, steel bolt, 16 millimeters in diameter. The sheathing is to prevent rack and shear. There are purling connectors which connect the stud to the saw plate. There's also a gang nail plate which is cut, which connects the saw plate also to the stud. The whole purpose of this type of construction is to pretty much bolt the saw plate onto the concrete beam, which would keep it sturdy.
Here, we are looking at where a timber-framed roof meets the sole plate.
So the sole plate is always of a 3x4 Purple Heart sole plate. The sole plate is fixed to the wall stud, which would be a 2x4 wall stud. The wall stud could vary in size, but this is the wall stud here. We have the gang nail plate, which is fixed on each side to fix the wall stud to the 3x4 Purple Heart top rail. We also have, as we had shown in the other details, where you have this is a purling clip, which in addition fixes the Purple Heart top rail to the stud. The stud could be of Purple Heart, or it could be of pitch pine. And in addition to this, you will see this piece is 12 millimeter thick sheathing board. This plywood, which is used as sheathing, and this is intended to prevent rack and shear from the effect of the hurricane. And this plywood lines the interior of the house, of a timber frame house. You also have this with ceiling, a 10 millimeter thick plywood ceiling. Again, this provides rack and shear resistance in addition to the walls. And this piece here being what's called a diaphragm cord. This diaphragm cord nails the Purple Heart top rail to the ceiling. So it allows, this is a link between the ceiling and the Purple Heart top rail, so that the walls cannot be pulled apart, because the ceiling acts as a horizontal diaphragm. This is a ceiling joist. Again, this is a 2x4 Purple Heart ceiling joist, or it matches the rafter. 2x4 ceiling joist or ceiling tie, and that stops the ends of the rafter from being pulled apart.
On a cautionary note, here is a tip in relation to the interior surface of a house with plywood ceiling and sheathing.
You will need to make these fire resistant, either by lining the interior with gypsum board, or applying a fire retardant paint to the interior, so that in the event of a fire, that the ceiling and this board and the sheathing board doesn't readily ignite, and you find yourself inside a bonfire.
A hip-roofed home of a cubicle form is considered to be one of the best configurations to use in high winds or hurricane-prone areas.
This next piece has to do with the construction of a hip roof. Now, this is a part of the hip roof, hip joint. This is called the king rafter. This is a raft that aligns with the ridge board. As you'll see here, there's a raft. This is a ridge board, and there's a rafter that extends, which aligns with the ridge board. And so this king rafter is fixed to the ridge board using a gang nail plate. There are two gang nail plates. If you can see through here, there are two gang nail plates that fixes this ridge board. Two gang nail plates that fixes the ridge board to the king rafter. And then you put the hip rafters with three rafter connectors are then fixing, and also there are 4 10-penny nails that are driven directly from the hip rafter into this joint. And then in addition to that, you have this joint shows 3 rafter connectors that fixes the hip rafter, to the ridge board. This is a 2x3 Purple Heart rafter, strap tie, I should say, that fixes the last common rafters. And then you see there's again, you have here, which would be the purling connectors that fixes the strap tie to the ridge board. And then this strap tie is nailed into the last pair of common rafters using 4 hardwood nails. This is a complete assembly of the hip joint. What I showed you earlier, that was a partial assembly of it to show how the pieces fitted together. So what you're seeing here, this is the ridge board. There's a sloping piece. This is the king rafter, which aligns with the ridge board. This is the last pair of common rafters. If you notice here, there's this common last pair of common rafters. There's a multi-purpose strap that comes right over the top. It's a 2-foot-long multi-purpose strap that comes over the top, and it acts as a tie to stop the top of the rafters from pulling apart. And this is your hip rafter.
Call the Building Standards Authority at 426-2775 for sound advice on how best to protect the investment of your home or small building against the perils of natural disasters.